real numbers. Who can tell me what is the meaning of real numbers? Numbers. What is the meaning of numbers? Okay. First step, we have counting numbers, natural numbers, integers, rational and irrational numbers. Who can tell me the difference between the counting numbers and the natural numbers? What is the difference between counting and natural numbers? Who can tell me? Can you hear me clear?
Yes.
Okay. Do you know the difference between the counting numbers and the natural numbers? Okay. When you start to count something, when you start to count something, you start to count 1, 2, 3, 4, right? Or you start to count from 0?
No, start counting from 1.
Yeah, excellent. So counting numbers start from 1 and it's infinity numbers, okay? But natural numbers start from 0. So natural numbers start from 0, but counting numbers start from 1. So the first set that we have is counting numbers. And by the way, counting numbers is a kind of natural numbers, okay? And then if we add 0 on the counting numbers, this means the whole natural numbers, okay? What about if I have negative number? Negative numbers are natural numbers?
No, because they are negative.
Yes, they are less than 0. They are negative numbers. So this is why we call negative numbers when we have the negative numbers like -1, -2, -3. This is called integers. So the integers have the positive numbers and the negative numbers. So if I have a fraction like half is an integer? No. Integers must be whole numbers with positive numbers or negative numbers, but it's not a fraction or a decimal. Okay, 0. 0 is a positive number or a negative number? Who knows this? 0 is a positive number or a negative number? 0 is neither positive number nor a negative number. It's not positive and not negative. Okay, so after the natural numbers and the integers, we have, if I have a fraction like half, how can I classify this number? It's not a natural number and it's not an integer. So what will be the name of it? This is
non-integers.
Yes, non-integer and rational number. So rational number is a non-integer number. Okay. But we have rational number and irrational numbers. We need to know the difference between them. Okay. Let's say it again, the kinds of real numbers, rational numbers, and irrational numbers. Real numbers, as we said, rational and irrational. So the rational numbers, like the integers, the positive numbers, and the negative numbers, and the fraction. Okay, so we can write the rational number as a fraction of 2 integers, but we have a rule. Can we have in the fraction a denominator that is equal 0? 2/0. Can I have this fraction? Can I write 2 over 0 or any number over by 0, divide by 0?
No.
No, it's undefined. If you tried it on the calculator, he will tell you that this is undefined or math error. Okay?
Yes.
Why? Do you know why? It's very easy, by the way. Division is the inverse of multiplication, right? If I said
Yes.
6 divided 3 equal 2.
2.
How did you know?
Because 2 multiplied 3 equals 6.
Yes, because 2 multiplied by 3 equals 6. But if I did 2 divided 0 equal what? Equal what? Can I do 2 divided 0? 0 multiplied by any number will not give us 2. 0 multiplied by any number will not give us 2, or will not give us a number. So this is why it's undefined. It's a math error. We can do it like this. Okay, if the voice is lagging, please tell me.
It was a bit lagging, but now it's good.
Okay. Okay, so written in a decimal form is terminating and or repeating same pattern of numbers. Okay, do you know what is the meaning of terminating? Rational numbers can be terminating numbers or recurring decimal. Okay, what is the difference between terminating decimals and recurring decimals? Okay, let's take an example. If I wrote a number like 1.75, this is called terminating decimal because it ends. 1.75 is the answer. Okay, but if you do 2 fractions divided by each other and the answer is like 0. Yes.
معلش الشاشة ثابتة ما بتتغيرش خالص.
Okay. طيب, I will share it one more time. وبرضو if you have this problem, please tell me. Can you see it now?
تمام يا مس.
Okay, thank
Yes.
you. Okay. If it happens again, please tell me. So,
Okay.
terminating means that I have an end answer, specific answer, like 1.75. It's end like this. But if I divide 2 numbers together and the answer is like 0.2466666, this is called repeating or recurring decimal because the 6 is repeated here, and we can refer to this number by 0.246, and we will put a dash above the 6. This means that this number is repeated. Okay, so it's clear now the difference between terminating and repeating?
Yes, thank you.
Okay, you're welcome. Okay, I changed the slide. Is it changed for you now?
Yes.
Yes.
Okay, examples of rational numbers. 16, half, 3.56, -8, 1.333, and -3 over 4. 16 is a whole number, so it's a natural number. Half is a rational number because it's a fraction. 3.56 is a rational number because it's a decimal. -8 as an integer, and we said that integers is rational numbers. 1.333 is a repeating decimal or recurring decimal, so it's a rational number. And -3 over 4, if we convert it to decimal, it will be -0.75. Okay, so this is the examples for rational numbers. So What do you think what will be the irrational numbers? Anyone can guess what will be the irrational numbers? Irrational numbers like what? Can anyone give me a hint? Try to think. Okay, irrational numbers are numbers that never have an end. So irrational numbers are what? The numbers that never have an end, like the non-perfect square root and the pi. Okay, we will explain it later. Okay, here you have a question here. Can you write 16 as a ratio? Can you write 16 as a ratio? Can you write 16 as a fraction? That's asked by another way. Can we write 16 as a fraction? Yes, of course. If I wrote it as 16 over 1, it's a fraction like this. And fractions are irrational numbers. And of course, 16 over 1 is equal 16. So irrational numbers is the numbers that never ends, never ends. Anyone tried before to make pi? Pi is equal what? Who can remember? Pi is equal what? Pi. We have two, Ahmed here and Akram and Noor and a lot of students. Can anyone tell me pi is equal what? Pi is equal 3.14 or can you tell me please? 22 over 7. Okay, the voice is a little lagging. I don't know this problem from my internet or your internet. But if I have any problem, please send to me on the chat. Okay, can you please try to do 22 over 7? You can do it on the calculator, by the way. 22 divided by 7 is equal what? 3.14285 blah 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 blah. It's
yes, a lot of other numbers.
Yes. So irrational number is a number that cannot be written as a ratio or a fraction of two integers. Written as a decimal are non-terminating and non-repeating. Never end, and it doesn't have a specific pattern. Okay, like the first example when we said 0.6666. So this is not happened with irrational numbers. Like non-perfect squares. Of course, all of you know the square root. Okay. What is the difference between perfect squares and non-perfect squares? Can you know? Okay, let's take an example. Square root 2, square root 5, square root 9, square root 16. Okay, square root 2 is a perfect square or non-perfect square? Square root 2 is a non-perfect square root.
Yeah, it's non-perfect.
Yes, yes. Can you please do it on the calculator and tell me what will be the answer?
It's 2. It's the same.
No, the answer will be 1.4142135624. So it non-repeating, okay. So it's not recurring and it's not a perfect square root. Perfect square root means two same numbers multiply with each other. Give me this number. or the square root that he gave it to me. Okay, 5 is a perfect square or not? So 2 is non-perfect square. Square root 5 is non-perfect square. No two same numbers will be equal 5. Okay, 9 is a perfect square or not?
Yeah, it's perfect
Excellent, thank you. Why?
because it's equal 3 in the end.
Yes, because 3 times 3
Whole number.
9. Yes, it's a whole number. So square root 9 give us 3 or a whole number. Okay, 16 is a perfect square or non-perfect square?
It's perfect.
It's perfect square because it will be equal what?
4. 4
Excellent.
multiplied 4 equals 16.
Excellent. Thank you, Noor.
You're welcome.
Delicious.
Okay, thank you. And the pi also is irrational number. Okay. Integer is one of the subset of rational numbers. We said that integers is a subset of rational numbers. Again, integers is like what? Integers is like what? Integers is a positive number or a negative number, and it's a rational, it's called a rational number. And if we want to write it as a fraction, we will put 1 as a denominator, as we took an example on 16, if you remember on the first slide, I think. Rational numbers can be written as ratio, or in other words, as a fraction. Okay, what are integers? Integers are the whole numbers and their opposites. Okay, so what is the opposite of 2? Okay, let's make a competition. I will wait for your answers on the chat. I will give you a number and you will send me its opposite. Okay, let's do it as a competition. Ready? Please try to participate. Okay, what is the opposite of -20? Send it on the chat.
The chat is disabled.
The chat is disabled.
Yes, we cannot write anything.
Okay, why? Okay, I will send something on the chat and tell me if you receive it or not. Let's go. You receive it?
Yeah, we received it, but we cannot write.
You cannot reply. Okay. So maybe
Yes.
there is something on the setting for the session. I don't know. Okay, so anyone tell me what is the opposite of -20?
Is it 20?
Excellent. -5?
5?
10?
-10.
Excellent. 0? We said that 0 is...
Yeah, it's 0, yes.
Yes, it's
It's
neither...
half.
Yes. Okay, whole numbers, it's very easy. Whole numbers are the counting numbers and the natural numbers. Okay. So we can make a small chart to summarize our lesson for today. Okay. Let's share a whiteboard to summarize the lesson for today. And of course, this is not the complete lesson. This is only a quick brief about the first lesson, okay, about real numbers. So
Okay.
real numbers is divided to what and what? Who can remember? Real numbers is divided to rational numbers.
Rational and irrational.
Okay, excellent. And irrational numbers. Okay, rational numbers is divided to what?
Whole numbers and integers.
So whole numbers is a set from the integer numbers. So we can say that it's divided to
Natural
integers, and non-integer. Okay. Integer numbers have what? What do we have in the integer numbers? We have negative numbers and whole numbers. We have negative numbers and whole numbers. Okay, whole numbers have what and what?
Negative and
No. Integers is divided to negative numbers and whole numbers. What is the meaning of whole numbers? If you remember the chart, the pie chart that we wrote at the start of the session, whole numbers include counting numbers, and if we add 0 on them, it will be natural numbers. So whole numbers means 0 and all the other natural numbers, right?
Right.
Okay. What about the non-integer? Non-integer is like what?
Negative integers.
No.
Negative numbers.
Here is the negative integers or the negative number. It's already non-integer. Non-integers is the decimals and the fraction. Right?
Right.
Okay. So the kind of the decimals, we have 2 kinds of decimal as we said before. Terminating. Can you remember the meaning of terminating?
Yes, that's end.
Yes.
Ending.
Yes, it has an end. A decimal that has an end. And the other one is recurring or repeating decimal. Okay, so all the rational number is clear now?
Yes, thank you.
Yes, and irrational number, as we said, the number that never ends and it's not recurring, never ends and it's not recurring. So let's write it. Can you give me example on irrational number? Never, numbers that never end, and it's also non-recurring. Okay, examples on irrational number, like non-perfect, square, and as an example, pi. Okay, I don't know we have time to take an example or not. Okay, no, we will not take an example now. I think this is a quick brave on the first lecture.
Miss, the voice is still lagging. Your voice is still lagging. We cannot hear you.
Okay, wait a second, please.
It's good right now.
Okay,
Yeah,
thank you.
yes.
Thank you. Okay, did you understand the real numbers?
Yes, thank you.
Anyone have a question? Thank you, Prep 2. I enjoyed the session with you today. Thank you for this session. Bye. I have to close now.
Bye. Thank you so much. Bye.
Thank you for me. I enjoyed with you. Thank you.
Thank you.
Bye.
Bye.